Maybe we could send it out to the other people and they can watch. All right, so did everyone install the software?
Yes, sir. I installed Octave.
Yeah, did anyone have trouble installing it? Or didn't install it as yet? All right. Let me just open up Matlab. Are there any electrical students in the room right now?
Yes, sir.
Yeah, you ever did projectiles? Like projectile motion?
Yes, sir.
Okay, good. All right, so I found a little program about projectile motion. Let me open it up. Right, and essentially what this is to show you what you can accomplish with Matlab, right? So I think yesterday in Mr. Sills mechanics class, some of the mechanical engineers did some projectile motion questions, right? So this is some code. It's quite a bit. It's about like maybe 300 lines, right? And it's a lot of code. And what this program sets out to do is to solve projectile motion questions. So if I had some problem in my life, mechanical or electrical engineer, chances are I can write a MATLAB program to solve those questions and solve any different variation of that question. So this is what's being done in this projectile motion script, right? So again, right inside my computer, this is just some file named projectile.m, and inside of it is just code that's typed up, right? But a lot of code, right? Okay. Let's run this program. Run. You can just change folder when it stops you. And what this program does, where'd it go? Here, it launches this window, right? And it asks us for values, the initial angle in degrees, whatever the question might be, the projectile question might be, could be 70, right? It asks for initial lateral distance and initial height. So let's say we're launching something from a building that's 10 meters tall or 7 meters from some point laterally, right? We can put those values in, and our initial velocity in meters per second, we can put in something like 600 meters per second, right? Then we can just press OK. And what it'll do, it'll generate some graphs, right? That tracks the projectile trajectory. And you can see here, you have the height in meters, right? And here, the lateral distance in meters. Of course, this is times 10 to the 4. And then you have different plots. Projectile height is a function of time, projectile velocity is a function of time, all kinds of different plots. Of course, you can vary your program as you might see fit. And then here at the end, we have a little pop-up. It gives us the things we might be most interested in. The total time of travel, we get 114 seconds, things like that. The time until the top, which is at this peak, so halfway, 57.47 seconds, right? Then the horizontal distance travel is 23,000 meters or 23.6 kilometers and different things like that. So why I showed you this is that this is something you guys have been working with in class. So I'm trying to show you how MATLAB can be used to solve problems in a class. And additionally, at the end of the program, we can have this analysis graph, right? Where we use different angles or source of different angles, of course, the same initial velocity, and we have different trajectories. So we can see how the angle affects the trajectory of the projectile. right? And from this, we can do some sort of analysis. So whatever your field is, whenever you're faced with a problem, you can use Matlab to do analysis, to make programs, to make your life easier. You can write programs that can solve the problems right away. And of course, like at the end, plot things for different angles. Maybe as an electrical engineer, you can plot different values for different resistances, different voltages for different currents, right? Now, of course, this program is very complicated. I'll still send it to you guys so you can look through. You might not understand a lot, but as we keep learning more Matlab code, right, you can go back to it every now and then and see if you understand more of what's going on. All right. So with that being said, let me just continue with teaching you guys more things about Matlab and more things to type into the command window. All right. So again, this is the command window. Let's just clear the screen and clear the workspace. Let's bring the workspace back out. Right, so we can see the variables populate. Okay. So did everyone get a chance to go through the exercise 1 and 2, the two little PDFs I sent with just some basic Matlab input functions? Did you guys get a chance to go through those?
We didn't get any PDF file.
Yes,
Didn't,
sir.
didn't your class rep send it out to you guys?
Yes, sir. Yes, sir.
Load in the
Yes, sir.
Okay, so apparently some people got it and some people didn't. All right, so at the end of the class, just remind me and I'll email it back out to everyone, all right? So just remind me at the end of the class and then I'll email it to everyone, right?
Yes, sir.
So you download Matlab, then you guys practice like typing in some simple stuff, some simple commands, anything like that?
Yes, sir.
Sorry, I got to download Matlab, but I get in some issues. I'm not getting to go into it.
So I don't
All
know.
right, just please give me a few. Yeah, what issues you getting with it?
Sir,
Yeah.
actually, I downloaded it. I don't have a computer at the moment. I downloaded it on my mobile phone.
Okay,
And
and
I'm trying to go into it. I'm not getting through.
is it an Android phone?
Something with the email address with, and I'm using my email address with the right password and still getting problems. Not getting.
No, but did you sign up for a Matlab account? Okay, so if you want to use it on your phone, you're gonna have to come into like mathworks.com. And then, well, I'm logged in here already. Yeah, you can sign in, and you can, if you don't have an account, you can click create one, you create one, and then you sign in, right? So like mine is my email and then my password, right? And you sign in, and that's how the app should work. Okay, so you need to create an account and then it should work. If anyone else have any issues?
So that would be like a Matlab account.
Yeah, it'd be like a online Matlab account. Yeah. Someone else had a question?
So excuse me, so you're saying that the app could actually work on the phone, the program could actually work on the phone?
Yeah, but it'll be very limited. So you can use it to like do basic stuff. Again, so far we've only been doing basic stuff, so you can use it for those. But when it comes to maybe more advanced code, it might run as fast on your phone. All right.
Okay.
Yes, so my next class I'll try to get the computer.
All right, good. Great. Anything else? All right. So as I was saying last week, and hopefully enough of you played around with Matlab that you can follow, we can do the regular things like basic calculation stuff. We can do sine of pi, right? Basic things like that, right? And we can do basic calculations. We can do multiplication, 6 by 8, 48, and everything like that. And we talked about the workspace, about how variables pop up in the workspace.
Sir,
How variables pop up in the workspace. Yeah, go ahead.
are these commands already built into the program?
Yeah, you just type and they work.
Okay, sir.
Yeah, so you just type, as long as you install, you just type and it works. Right, good. So we covered a lot of basic stuff last week, a lot. So now we're just gonna focus on using built-in functions and constants in Matlab. So Matlab, because of how it's used by engineers, and there are a lot of constants and functions that engineers commonly use, such as the trigonometric functions, right? Trigonometric functions, and that's like your sine, your cosine, tan, and all others, right? So as I was said, one built-in function is sine of x, and you can put whatever value x is, maybe something like 30. Right? Now notice that this sine here computes the value in radians. If you wanted to do it in degrees, you would do sine d, right? And we know sine of 90 in degrees of 90 degrees is 1, right? So sine d for degrees and sine 30 for the regular radian version of the function. And similarly with cosine. Now, these are functions, these things that we type out with the brackets, with the two parentheses, right? These are functions and we put some inputs inside, right? And then internally they do some kind of computation, right? So what is a function? A function, we can think of it as just a little block, a little functional block. Okay? That is a horrible square. Right. We can think of it as a block. This is the function. Okay. And what it does is it takes an input and it produces an output. So in this case, the sine of x function, right? It takes something in, like the value that we want, the 90 degrees, right? And it outputs something like 1, which sine of 90 is 1, right? This should be sine d, the degree version of the function, right? So it takes inputs and it produces output. Similarly, for the function sqrt of some value, right? It's going to take a number, maybe the number 4, and it's going to calculate the square root of 4, right? And it's going to output the square root of 4, which we know is 2, right? So there are all sorts of built-in functions in Matlab. Just a few, the same square root one we were talking about. Square root of 4 is 4. Is absolute value, right? So minus 4, absolute value of that will be 4, right? Removing the minus sign. The symbol, you might see it in mathematics often as this, something like minus 4, absolute value is equal to 4, right? And there's also exponential, right? Something, this here refers to e to the x, and so on and so forth. Many built-in functions, anyone that you might need. Right. Okay. Now, in addition to that, there are also these things called constants, things that we use often. One such constant is pi. So if we type pi, what it outputs, it's the value for pi, right? 3.141592, and so on and so forth, right? Right? Now, internally, this constant is stored to really high precision, as high as you might want, right? But what's displayed here is based on how you format or set up the window, right? So just like last time, we can assign variables to certain constants or certain derivatives of constants, like x, we can assign that to being pi divided by 2, right? So what that's going to do is going to take this constant pi that's stored within the Matlab environment, is going to divide it by 2 and assign that value to x, right? So not only can we store numbers like 4 and 5 and 6, we can also store these constants, right? Pi. Right. Now, additionally, we can assign the outputs of functions. So as I was saying, sine d, the degree version of the sine function of 90 is 1. We can assign the output of this function to the variable x. So x, we can assign that to be sine d of 90. So what's the value of x going to be here? The value of x is going to be 1, right? So x is equal to 1, even though we typed x is equal to sine d of 90, right? It evaluates the function and then assigns that value to the variable x. Now, let's try something a bit different. Let's assign a variable z the value sqrt minus 9. So what's the square root of minus 9? Well, the square root of a negative number is generally a complex output. So if you press enter here, we're going to see something a bit weird pop up. We're going to see z is equal to 0 plus 3i, which in your mathematics classes, where you guys know as a complex number. So the Matlab environment is also prepared to handle complex inputs and outputs in this form, right? So you see 3.000 I, right? I. And we know I, for mathematics, just refers to the square root of minus 1. So if you want to do complex arithmetic, you can do it in mathematics, in our Matlab as well, right? Okay. Now, the number of zeros here depends on how we set up the environment. Again, when I typed pi, we saw 4 show up. Now, if I type this other command, format long, as enter, then I type pi again, right? We're gonna get more decimal places. And if I type back format short, and then type pi, we get less decimal places. So even the amount of decimal places that are displayed, we can control, right? So when you're typing up your projectile program or a program to display resistance or whatever degree of accuracy you want, you can obviously format your outputs, right? Good. Now, script files. As I've said before, Matlab files or script files are .m files. So if you want to type some code that you want to execute constantly or execute in order and save it, you can type it in a file, right? Or alternatively, you can just use the Matlab built-in editor. You can come here, you can click new script, and that's going to open up some sort of notepad. And you can type something like radius is equal to, or let's not use radius, let's use r is equal to 3, semicolon. Right? Then area is equal to pi times r to the power of 2. Okay? And this is just a function that calculates the area of a circle of radius 3. Right? And we can run this. Of course, we need to save it. We can save it as simple area program. Area program. Just press save. Right? Save. Simple area program. Oh, so we can put spaces in the Matlab program. So we can need to rename this. Inside of the spaces, we can put underscore here, or we can do alternating caps. So just type simple for the first word, and then everything else common, then the next word, capital A, everything common, then the next word, capital P, everything common, or you can use underscore, whichever one you want. Now, when we run this, again, it's just going to calculate the area for that circle, right? 28.2247. And this is a code, this is on per program. Imagine if you had a lot more code, maybe you're doing something like moments or some bit more complex program. You can have values in here. You can have things like G for gravity being equal to 9.81. And you can just pop open your script, come in, change the values, right? So in this simple program, if you want to change the radius, we just come back in, we change it. Okay, what's the area for a circle of radius 2? Save the script and run it, right? And now we'll do an area for a circle of radius 2. And then we can build upon these simple programs and just get more complex, right? So that's the script. Yeah.
Sir, could you please run out to save a program again?
Save a program. Okay, great.
Because I don't know if you did it in last class. You did it in last class,
good.
sir?
So you can create one by just coming here and click new script here in Octave. If you guys are using Octave, let me open that up. Right. So in Octave, you come to this thing here, new script, right? Or just new, right? New script right here. Just tap it and it'll open up an editor window, right? Like this. And in here, you can type up the code that you want to execute, right? Line by line by line. And then just save, like Control S, or I think this here is save file, save as, right? And you save your code. In Matlab.
And then you save it as
yeah.
.m.
So when you click new script, right? And then you try and run it, it's gonna tell you to save it, right? And it's gonna automatically put .m there, right? And you type up whatever name. Remember, the name can't have spaces. So you only need something like whatever it is, like for this one area. If you want a space, you can use the underscore, right? Or you can just put the next letter in capital to help differentiate between different ones, right? Okay. So if you use it from the Matlab environment, it automatically saves as .m. If you wanted to not open up Matlab, just like create a file, you can just create a new text document on Windows. And here, of course, you need to go into My Computer, this PC, View, and turn on file name extensions, right? Here. And you can save this here as a .m file, right? Remove this txt part and put .m. And it'll change it to a Matlab file, right? And then you can use that same text editor to open this up and type code in here, okay? If you prefer. Some people have more fancy text editors that they like to use to write code, and you can use those as well, right?
So I'm using Octave, sir.
Yeah, so Octave, as I said, you just click here, new, type up your code, right? You can do Control S to save it, and you save it somewhere. It's gonna automatically save as a .m file, right?
And the same goes to loading a file.
Yeah, so to load a file, you click here, open an existing file. And let's say I wanted to open that projectiles program. I go to my desktop, I will go to my folder where I have the program, right? I load up the projectile program here, and then it's already saved, so you don't need to save it. If you make changes, I can make changes, right? You can save it again, right? And then I just click run. Of course, I need to change directory, right? And then the program starts running. I type in my angles and my velocity and whatever other things I want to type in, and the program runs, right? So you can open an old one, right? And just run it the same way, right? So everything is more or less transferable directly back to Octave, right? If anything that you don't know how to do on Octave that I show on Matlab, just ask. Okay, so someone's in the chat.
Excuse me, you said something about rename something a file name extension. I didn't quite get that part.
Yeah, so I'm saying the extension for Matlab and Octave scripts is .m, right? If you want to see it on your PC, because most PCs don't show it by default, right? Usually you see new document, right? You wouldn't see new text document.m or new text document.txt or .docs, right? You don't usually see those. So to enable that, you come to your computer, this PC view, and just click file name extension so you can see the extensions, right? On Linux and Mac is different, but I'm sure you guys can figure that out. If you run in Linux, you should know about file name extensions, all right? Good. So where was I? We talked a little bit about scripts. So a script is essentially just a fancy text file that you write code in to save so that later we can execute it. It's a script file. It's a series of commands that we want to execute. All right. Now, let's talk a little bit about windows. So this here is the command window, right? If I were to click here and click minimize, it'll disappear and it'll go to the side. This here is the workspace window. And if I were to click here and click minimize, it'll go to the side. Current folder, same thing. Click here, click minimize, it'll go to the side. And if I were to open up a new script here, be everything. But if I wanted to see the command window back, I mean, just come to the side and it'll pop up. And if I click on it, it'll stay out, right? So you can rearrange and set up your programming environment however you want, right? It's the same thing for Octave, right? So let's put this back out, right? And it's the same thing for Octave. If you have any trouble doing it in Octave, just let me know. Where did the command window go? All right, good. All right, so let's talk a little bit about arrays. So first of all, what is an array? The first thing I should mention is that all the variables in Matlab are arrays, right? So when we type x is equal to 3, what we're doing is we're creating an array and saying the variable x is equal to 3, and there's only one element in that array. So in your math class, in linear algebra, you learned about matrices and you would draw things like these, 2, 3, 4, and you take these values from maybe simultaneous equations or things like that, and then you'd find the inverse of it, determinants, things like that. In Matlab, you don't need to do all those. We can actually input things as matrices and allow matrices calculation to be easier. You can simply just input a matrix, something like A. Let's call this matrix here A. And if we wanted to find the inverse of it, we can just type I and B, A, right? And it'll find the inverse for us. There's no need to calculate the determinants or things like that. That's one of the reasons why Matlab is so useful, right? Because remember, Matlab stands for Matrix Laboratory, right? Laboratory. That's what it stands for. So if you had a simultaneous, a set of simultaneous equations, you can just put the values into a matrix, calculate the inverse really easy, and solve for all those variables, right? Whether it was 3 variables, 4, 5, or 6, you can do it fairly easily with Matlab. If you were to crunch those numbers by hand, it would be pretty hard, right? So in Matlab, arrays more or less refer to matrices. Right, so let me get a new page. So arrays refer to matrices. What does that mean? So there are a couple different types of array. Let's start with a row vector. So a row vector. Row vector. From your maths class, you know what a row vector is, right? It's just a single row matrix, right? So one row one row of values inside, right? And here we store some different values. Could be anything. It could be 2, 3, 6, 9. In your math class, you would write that something like this, right? 2, 3, 6, 9. Maybe commas in between. In Matlab, we can store things as these variables. There's also things like column vectors, right? Or a column matrix, where you can store like this along the column. So there'd be a chunk of memory, and we carve out spots for different variables. So you put anything as 2, 3, 6, right? Anything you can put in there. There's also matrices that are arrays. So they just be like maybe a 2 by 2 block of memory. And we can store values in that as well. So you're saying 2, 3, 6, minus 9, right? So however you might want to store your variables, because in mathematics, we have column vectors, right? We have these column matrices and these row matrices, and we have these 2 by 2 matrices. So however you want to store your data to maybe do something like, let's say this matrix was A, to do something like find the inverse of A with a built-in Matlab function, we can. And we can store them however we see fit. Right? And there's also the scalar, which is what we've been using before. So scalar. Scalar is something like just the number 2, right? And this would refer to the command that we've been typing, x is equal to 2. So let's open up Matlab and see how we can create all these different column vectors, row vectors, and scalars and stuff. Let me clear. Okay. So we know the basic one, the scalar, x is equal to 2. Great, just one variable inside here. But an array is a group of variables, right? A group of variables of similar data type. So a group of numbers, a group of letters, things like that, right? So let's try a column. Actually, let's just try a row first. So x is equal to, and to create a row vector, we use the square brackets, right? These square brackets, and we type our number. So 2 space 3 space 4 space 5 space 6, right? What this is going to do, it's going to create that matrix that we are accustomed to when we do in mathematics, right? 2, 3, 4, 5, 6 is going to create it in a row. Now, another way to do it, right, is just like that, but instead of spaces, use commas. I put 2 commas here in a row, right? Good, and it's gonna do the same thing, right? So comma or space, or you can mix it up, right? Comma here, space here, same thing. And that's your row vector, right? To do a column matrix, the column vector, we can do something like x is equal to, again with our square brackets, right? Some variables, 1 semicolon 2 semicolon 3 semicolon 4. Now notice the difference. This one creates it down vertically in a column, and the previous one was in a row. So here a row and a column. So spaces and commas create rows, and semicolons create new column. Spaces and commas create new columns. So like this here is column 1, column 2, column 3, column 4, column 5, and these semicolons opposite into a new row, right? So 1 into new row, 2 into new row, 3 into new row, 4. But this here is stacked in a column, this here is stacked in a row, right? Let's see what else. Okay. Now, what if we wanted to create the matrix? So we did we did the scalar, check. We did the column vector, we did the row vector. So how would we go about creating a matrix, right? Because we want to solve these simultaneous equations in Matlab. Maybe we're doing some nodal analysis and we generate some equations from our circuits. And now we want to solve them. Maybe this circuit has a lot of loops and we don't able to solve so many simultaneous equations, right? We're lazy, so we're using Matlab. How would we generate this matrix? We'd say X is equal to square bracket, right? And then we start typing our variables. We know commas create new columns and semicolons create new rows. So if we wanted some 2 by 3 matrix, we do something like this. 3, 4, 5. Those are numbers. We want spaces in between them or commas, whichever you prefer. And we do semicolon to bring the next set down into the new row, right? And then we put our next set of numbers, 6, 7, 8. Of course, we want spaces in between them, right? And if you press enter, this creates this block, right? And you can add on a new row, 9, 10, 11, just like that. And we create this 3 by 3 little matrix here. And if you wanted to find the inverse of that, we just do in of X. Yeah. So this matrix here is badly scaled. So Matlab's gonna output a little error, right? But this here is the inverse or pseudo inverse of this matrix, which is very easy and might help you solve your simultaneous equation, right? Okay. Now,
Sir, what do you mean by badly scaled?
so it's a 3 by 3, and if you try to compute, can you compute the inverse of this matrix? How would you go about doing that? So it's more of a math thing.
I'm working.
Yeah, it's more of a math thing. So sometimes, you know, there's some matrices you can't find the inverse of, right? Or you can't find it using the methods that you normally use.
Like
Yeah, so sometimes
singular, non-singular.
yeah. So because I just made up some numbers here, the inverse for this matrix doesn't easily exist, right? Or you can't just pull it out of nowhere, right? So MATLAB's gonna warn you a bit. Most often than not,
Give you answers.
most often than not, the result is be accurate though. All right. So when they come across matrices like this, they output as the pseudo inverse, which is as close as possible to the inverse that they can calculate, right? So that's just what it is. When we start using matrices, maybe I'll talk a little bit more about that. All right.
Sir, one question. This fx, right? I see like this fx is only used when you start in the program.
fx.
I see some other instances you just use the double arrow instead of fx double arrow x.
Oh. So what this is just the live command window. So there are functions here and there are functions that are built into MATLAB, right? And you just type and they execute those functions, right? This here is maybe you have some particular category or some kind of library setup that you want to pull from. You can always switch that, right? But just keep it on MATLAB and it's fine. It's fx at the side here. Yeah, just keep it on MATLAB and it's fine. I don't know if Octave has anything like that. Let me check.
MATLAB is just like a general thing that would guide you to which specific category.
Yeah, so MATLAB is like, it just has all the basic stuff that you might need. So for the people that installed MATLAB, they had to check a lot of boxes, right? So depending on what you do, you might need different functions, right? You guys understand that? Like different engineers use different functions. That's essentially just what it is, right? So maybe as an electrical engineer, you might use something, maybe the Z transform. But every engineer would use something like Fourier series or maybe Laplace transform, but not everyone uses the Z transform, which is specific to signal analysis. So there are certain libraries that you can set up in Matlab to make your life easier instead of having to write functions like that, right?
Sir.
Yeah.
I have a question. I noticed while you were doing some of these examples, you were saying that Matlab is calculating to the nearest whatever, right? So the question is can we rely on Matlab to calculate everything? Is its calculation always correct?
Yeah, so it's the same way with the calculator, right? If you plug in 2 + 2 and you get 4, it's right. But if you plug in 2 + 2, but you accidentally hit the minus button, it's gonna output wrong. So if you type crap into Matlab, it would output crap, right? For the most part, as a first or second year engineer, whatever you type into Matlab, as long as it's correct code, it's gonna output the right answer, right? For the most part. There are some limitations, but those limitations are well beyond the scope of this course, right? I really doubt you'll be using Matlab to such an extent where it becomes inaccurate. Because even with my projectile question, if you were to take that program and just plug in the question from your mechanics class, maybe number 31 or something like that, you plug in the values, you're gonna get the right answers, right? Okay, does that answer your question?
Yes, sir.
Okay. So you can trust Matlab, right?
Can't or can?
You can.
Oh.
Sir,
Yeah.
when I
Alright.
download Octave, sir,
Okay.
I'm seeing two desktop icons, CLI and a GUI.
The GUI.
CLI. So
Uh-huh,
CLI is the command line interface. So the command line, it look like this and it's black and white. And you can type. I'm not too sure if I have an Octave command line interface. Let me see. Yeah, CLI. Yeah, so it's essentially the same thing. So we can go for 5 + 6 is 11, and it'll do the same thing essentially as the same live command window. But maybe like this is more applicable to people that use Linux, or maybe they have some kind of live desktop environment. Let me see if I type Octave here. Right. Yeah, so usually in Linux, when programs installed, you can just type Octave from your command line and it starts up. So that's why that version is there, right? It's not really useful in Windows. You can just open up the GUI and type up the code. Because sometimes from the command line, you might have a script. So you might want to type projectile.m, and you might want to execute that with the Octave program or something like that from the command line. But it's not really useful in Windows, right? So use the GUI one. You can just delete the CLI, the command line interface icon, or you can play around with it, right? So no need to worry about the CLI icon, right? Any more questions?
Not in a moment. Oh, you post the recording on Moodle, or you could send it to us, please.
Yeah, I'll send it to you guys, right?
Thank you.
Great. All right, and I'll email you guys the exercise sheets.
One quick question. How do you communicate with everybody from the class? Through the email?
Yeah, I'll start communicating by email from today. Last week I didn't have your emails. This week I do. So I'll communicate by email from this week. Right.
Okay, sir.
Sir, you favor Matlab?
I what?
Do you prefer Matlab over Octave?
Not really. I don't really have a preference. Octave is lightweight. On my other computer, I use Octave. This here, I use Matlab. It just depends. If you want to use Simulink, you can use Matlab. Matlab is better, right? Because Octave doesn't have the Simulink toolboxes and stuff like that.
Will we need to use Simulink during the course?
I will touch on it. It's not something you really need to pay a lot of attention to it, but it's nice. I will touch on it. I'll try and make it useful for you guys. And maybe it might inspire you guys to download Matlab and use it. But I won't make it such a big part of the course, right? Additionally, we also have to cover Multisim. I should probably mention that too, NI Multisim, which is just a simulation tool for electrical engineers, right? But maybe in a month's time. This year, like you have like oscilloscopes and voltmeters and stuff, and you can draw circuits on them and simulate the circuits, right? That's essentially what it is. But when we reach there, we'll cover that. Okay. Good. So as I was saying, you want a 3x3 matrix. This is what you can do, right? And you can multiply matrices by different scalars and things like that. So if you wanted to multiply, let's say some new matrix Y is equal to 2 times X, every variable in X is going to be multiplied by 2. So you can just scale this entire matrix up by 2. And you can do all sorts of things like that. And maybe next week we'll do some nodal analysis, right? Using the matrix, and you guys will learn that. Now, another thing about matrices, they're the same way we can dynamically assign variables. X is equal to sine D of 90, and that's going to calculate 90 and input 1. We can do the same thing with matrices, right? We can do X and we can put a square brackets. And then in here, we can put functions. We can do absolute value of -4. That's going to take the absolute value of -4, which is 4, and it's going to store that as the first variable. And then we can do, let me see, some calculation, maybe 5 to the power of 2, right? And then maybe let's do the same sine 90, right? But let's do sine 90. Good. And then what it's going to do, it's going to compute the absolute value 4 of -4 and put as 4. It's going to square 5, 25, and it's going to put that in. Calculate the value of sine 90 radians and put that in, right? So you can assign them dynamically like this. Okay, and it's still 3 variables. Right, good.
Sir, Matlab just give out answers in radians.
So there are 2 types of trigonometric functions. There's sine. So let's say sine of
I know they got radians
pi
and they got degrees.
divided by 2. Yeah, sine of pi divided by 2 is 90, right? This here is 90 degrees, right? So we press enter, we're gonna get 1. So now if we want to do sine of 90, but put in degrees, we need to type sin d, d for degrees, and then put our 90 in. So there are 2 functions, right? Sine that does it in radians and sine d for degrees, right? So if you want to use degrees, just type this function. If you want to use radians, type this function. Good.
Sir, what about the octave? Is this the same thing?
Yeah, it's supposed to be. Let me check. Sine pi divided by 2. 1 sine 90, but with the d, right? 1, right? Same thing. A lot of the commands, almost everything translate over to octave. Okay. So now I think you guys should maybe do some practice work, right? Like open up Matlab for yourself, and instead of having me type commands, you guys type commands yourself, right? So let me see. First exercise, not the first exercise, the first one I want you guys to do now. Try creating this matrix here. this one here in MATLAB, right? So open up MATLAB or Octave, right? Type some code, maybe assign the variable X or Y or my matrix, right? And create this matrix here, create this array, right? So everyone do that. And tell me whether or not you get through.
What is cool? Sir, did you have any issues when you download Octave?
No. Right.
It was working, but now it stopped work.
Stop work.
It says Windows script host access is disabled on this machine. It worked when I downloaded it last time, but
Do you have administrator privileges?
of course.
Try running it as administrator. If it don't work, reinstall it.
Oh boy.
All right. For everyone else not having technical difficulties, please try creating the matrix.
Sir,
Yeah.
what do you type again to clear the command window?
To clear, just clear all the junk. CLC.
Yeah, CLC.
CLC
I'm
clears
typing clear and I'm only seeing the
workspace clear.
clear.
Yeah. So CLC clear. Clears the junk out the window.
Sir, I think I gotta reinstall it, sir.
All right, go ahead.
It was working though. Why it's not working all of a sudden?
Software is like that, man. Like it's like that lot.
So can you go back on the screen? that
Oh
we
yeah,
have to
yeah.
do?
Yeah. Okay, good. Here, yeah. This one.
Or you don't need to include the big brackets.
These big brackets.
Yeah.
So what you do is you just type the matrix, whatever the variable you want to call it, X, Y, Z, let's use Z, is equal to open square brackets, right? And for new rows, so this here is like 1, 2, 3 rows, you put semicolon, right?
Yes, sir. I finished doing all the. I just want to know if you gotta get the big brackets around it when it's created.
Oh, you mean like for no, you don't need that when it's created,
Okay.
right? You mean like brackets here? Yeah, you don't need a square brackets there.
All right, cool.
Did everyone else get through? Anyone not getting through?
Sir, assign a name to
So
the
what's
matrix.
the difference?
Yes, sir. Sir.
Yeah, what's the difference?
What's the difference with the parentheses bracket and the square bracket? Let's see, using
There
both.
shouldn't be. I think Octave is a bit different, right? Let me see. X. Yeah, so Octave, this doesn't work. Ah. Yeah, so square brackets constructs matrices, parentheses don't. Parentheses are just to include functions. I think in Oliver's, the Matlab, you could use parentheses to create matrix, but now apparently you can't. So parentheses are like if you want to do some operations, you know, in mathematics, you guys had BODMAS and stuff, and you'd use parentheses to like separate different parts of the equation. Like if you wanted to do something like 2 plus 3, right? This then multiply that by 4 instead of doing 2 plus 3 times 4, and just be thoroughly confused which one to do first, right? So parentheses helps us specify the order of operations. Right? And the square brackets are used to create matrices. Right? So use square brackets for matrices, use parentheses for order of operations, and sometimes for functions, right? So like when we're doing sine of x, right? We use the parentheses after the sign to include the input. Right? Does that answer your question?
Yes, sir.
Okay. Good. Okay, so everyone get through, everyone create this matrix.
Sir, could you go back out to save a matrix in save a file, one of these files, an Octave file again?
Yeah, so let's open up the workspace, right? The workspace is here. Let's restore. Right, so all our variables are here, right? We want to save them. What we do is we type save, then we give our file a name, file name, then do .mat, right? And press enter. And now we can clear, and it clears the workspace. And if you want to load back that in, just type load, and then whatever you name your file. I named it file name, press that, and all the variables are going to come back up. Okay, good. Right, and if you were to
One quick
explore,
question. I see you put .mat. It doesn't have to be .m alone. It could be anything you choose.
no, so what this is a workspace file, right? A workspace variable file, right? This stores the variable. Scripts are different from saving your workspace. Does that make sense? So a script is code. Script is like code, like what we type in here. This, again, let's just load it. This file.mat is saving these variables, right? So let me explore my current folder here. Okay, let me just go to that. Oh, there's so many windows open. Right, if I try and open this with a simple text editor, open. I'm gonna open up in Matlab. Yeah, so apparently my computer can't open it, but what's gonna be inside, it's not gonna be code. If we try and open these .m files, right? If we try and open a .m file, right, it's code inside. We can read this, we can type this, we can edit it. What's inside this file name .mat is just our collection of variables, right? So it's two different things. This is like, maybe you want to save your environment and come back and work on your question later. You can do that. The .m is for saving programs.
So,
Like
sorry, for Octave, what do you have to put .what?
.mat too.
.mat as well?
Yep. X equal 4. Open the workspace, save.
Sir, can you antivirus interfere with this thing, sir?
With Octave? No, I don't think so.
Sure.
Yep. Yeah, antivirus shouldn't. Yeah, .mat for Octave as well. Okay, good.
So you got type save on the way.
Yeah, we want to name the file. Maybe.
On the command phase, on the command page, you got type the file
Yeah,
name.
save SAVE. SAVE. Name your file, whatever you want to name it. Okay. I'll resend the exercise sheet so you guys can go through all this stuff on your own time, familiarize yourself with it. Right. Okay.
I think I did the
Is that what you're
program
saying?
on my computer. The file.
What do you mean?
Find the file. But
You want to
got
try sharing your screen?
Just screen, right?
Yeah, I'm not
Sir?
seeing it. Yeah, you sharing?
You're not seeing the screen. You're not seeing the screen.
No. Okay, let me see. All right, maybe let me stop sharing mine. Okay. Okay, yeah, I can see. Save, and then keep typing. So matrix.mat, right? Okay.
Like that, sir.
Yeah,
All right. So what to do next? Just press
just
enter.
press enter. Yeah. Good. Now clear. So you should come out your workspace. CLEAR. So look over your workspace, the variable
Sorry, I
X
just
is
pressed
still in.
TLC. Sorry,
Yeah,
press
so
TLC.
so you need to clear it out of your workspace so that the variable X from your workspace. So below that is your workspace.
Sorry,
So
get
come down to the left.
over here.
Yeah, above, right above that. Yeah, you see that variable X?
Yeah, where the variable is.
Yeah, good. Now go back to the window and type clear, CLEAR. You press enter. Good. Now go back to the workspace. The variable X is gone, right?
Oh, okay.
Good. Now
Yeah.
type load and your file name.
Pardon?
Type load, LOAD, LOAD. Yeah, matrix _1. Yeah, and press enter. Good. And now go back to the workspace. You see a variable pop back up.
Yeah, sir. But
Okay, so
also
it's the
make
way
it come back on the
how to make
command
it.
window. Come back on the command window. It wouldn't come back.
It's on the environment. So just type X into a command window. So just type X because that's the name variable and press enter. Good, and that's it. Right, that's the same matrix that you stored.
Oh, so what? So basically, what I could do is press this exit right now, and I won't come back to this exact page.
Yeah, later you just come back. You
So press
should be in
exit
the
now.
same folder. Yeah. Okay, so you need to know where it's stored.
Yeah, this is the thing, sir. I want to know where to store it. Another
Okay,
thing.
so come here to your file browser, right to the left, where you see contacts, desktop, documents, everything up here.
Okay.
Yeah. Let's scroll down. Yeah, you see the files are stored here. C users Cleon, right? File matrix.1.mat, right?
Okay.
Good. So you can close, you come back to right there, and as long as you're in that folder, you can type load and it will load the matrix. Right?
Okay, sir. Thank you.
Good. Anyone else?
Wait, what I do after? So what I do after I press after I come out to get back in? Go into the folder and
Just type load the same way you load here. Load matrix _1. Same
load the
thing.
file name.
Yeah.
Okay,
Good.
sir. Thank you.
Good. Anyone else?
Sir, I'll just stop here, sir.
I stopped it for you.
Okay, thank you.
Sir,
Yep. Go ahead.
if you close back the program, right? And then if you close the program, then you open back the program again and you just type X, the matrix will show up.
So if you close the program, like here, like you got a workspace here. If you close it, it's not gonna save unless you set Matlab to save.
Oh, when you save it already, right? And then you close the program. Like if you're going to shut down your computer, you shut it down, you start up, then you open back Octave, and you just
Yeah.
type X. And you
No,
type X.
you need to type load, right? You need to load back your save file.
Oh, okay, sir.
Yeah. Right, you need to load your save file. What am I sharing? All right, good. So I think we can call it a class, right? I'll send the exercise that you guys work over. And next week, we'll look at the projectile question on Wednesday, right? We'll try and answer it using Matlab, maybe explore the code. I'll send you guys this code of the projectile program. And maybe for Friday's class, we can look at some circuit analysis using matrices, right? So for homework, look at how you can use matrices to solve simultaneous equations, or maybe apply them in some kind of problem you're doing in your mechanics course, in the electrical courses, right? So just research on that and practice, go through the exercise. I'll email the exercise to you, right? Good. And if you still haven't installed Matlab yet, or your Octave keep crashing, right? Try and get that resolved next week. I think that's enough for now, right? So practice.
Sir, one more thing. The command history. How do you clear that part? Or that you already cleared the part?
CLC here. Like, let's say I type some stuff. CLC clears that off. CLC.
Like I'm talking about for the Octave. I got like a command window at the back, like everything you type.
Yeah.
When I press CLC, it's only clearing the command window, but not the command history. Like if you understand, like at the bottom there on your left.
Oh, the command history? Well, no, this is just the history of commands. You want to clear this?
Oh, so that has nothing to do with it. You don't have to clear that or anything.
No, this is just like, because sometimes you type code and you use it often, you might want to, what was that code I typed to do this thing before? So you might want to scroll back up and see what that piece of line was, right? Was that code Sarah was saying? Oh, that was sine B to do degrees, right? So you have your history here if you want to check back anything. Yeah, and you can filter it, right? You say, what was that code to do sine degrees? Just type sine and be like, okay, sine B. That was the code you can search with, right? In case you forget anything. Good. Okay, so that's it. That's all I have for you guys. I'll send the exercises and start thinking about ways that you can create small Matlab programs to solve problems in the engineering courses, right? Start thinking about how would I go about doing circuit analysis with Matlab? How would I create the projectile program that plots the graphs like I showed you guys, right? Start thinking about things like that. And from next week, we're going to start doing the projectile question with Matlab. And then Friday, we'll do some circuit analysis with Matlab. All right. Thank you guys for coming. That's all I have for you. You can go ahead.
Sir,
Hi, sir.
I want to know, we have a